can start now.
Okay, okay. Screen visible?
Yes, bro.
Yes.
Yes.
Okay, okay.
Yes.
So basically, in gravity method, we use two type of gravity. One is relative gravity, another one is absolute gravity. So first of all, discuss the what is the meaning of relative gravity. So in relative gravity, gravimeter compare the value of the gravity at the one point with another. They must be calibrated at a location where the gravity is known. That is where at one point we know the gravity, and another point we compare the calibration by obtain the relative gravity. This is the relative gravity, or another one is absolute. In absolute gravity, we measure the local gravity at a particular point. So we use the different instrument for the measuring absolute gravity. And one is the simple pendulum. We know that by measuring the time period, or we obtain the absolute gravity at a particular point. Another instrument is the compound pendulum, which is called Henry Cater. So the process of measurement of absolute gravity for Henry Cater is that, uh, yeah, this is the diagram for Henry Cater. We have two block. One is the wood block, another is the metal block. We represent that W2 and W1. And this is the key, and this is the weight for measuring the center mass of the rod. And once we obtain the time period for the wood block, and another one time period we obtain the metal block, the comparison the both the metal block and wood block, or put the value in this formula, we obtain the for gravity at a particular point. This is the Henry Cater pendulum for measuring the absolute gravity. And a third one is the instrument for free fall method. In free fall method, we use Michelson-Morley interferometer. We have a laser. Okay, we have a laser and a detector. And one is the retro reflector, and another one is the another retro reflector, which is reflect the ray light. In the, all the system, we use the constructive interface and destructive interface by measuring the time period, or by the put the this formula, or we obtain the absolute gravity at a particular point. This is the third instrument. And fourth one is the rise and fall method. In this particular method, we use the sphere glass and two source. One is the S1, and another one is the S2, and we obtain the two slit. And by measuring the in this particular instrument time period, which is fall to the pass through the source one and pass through the source two, and measuring the time period both the source S1 S2, and put the value this formula, or we obtain the gravity at a particular point. So this type of the instrument by measuring the absolute gravity at a particular location. And after that, we discuss the relative gravity instrument. In a relative gravity instrument, we use two type of gravimeter. One is the stable type gravimeter, another one is the unstable type gravimeter. The basic difference between the stable type gravimeter and unstable type gravimeter is that in a stable device, once the system has become disturbed, it returns to the original system. That is, it means that when a stable type gravimeter, we have the disturb the system of the equilibrium point, and after the sometime it's come to the equilibrium point. But in unstable type gravimeter, once the system is goes from the equilibrium point, it never come to the equilibrium point. No, it's in an unstable type gravimeter, we have a external force which is opposite to the opposite to the Hooke's force की बात करें. So this is the basic difference between the stable and unstable type gravimeter. And the stable type gravimeter basically use of the Hooke's law, and we use the compensate with the springs, and by measuring the gravity difference. And in unstable type gravimeter, we use two type gravimeter. One is the Lacoste-Romberg gravimeter. Another one is the Woden gravimeter. The basic difference between the Woden gravimeter is very light and cheap and for easily calculate for the and traveling also we can easily buy Woden gravimeter. In Woden gravimeter, we can automatically compensate temperature, but generally use low cost or Romberg gravimeter, which is also used in a marine area airborne survey. And in low cost Romberg gravimeter, some disadvantage like it notes a compensate temperature during the time and early morning and afternoon. These are the some basic advantage. And in both the unstable gravimeter and stable gravimeter, we use the zero length spring. The meaning of zero length spring is that when we remove the all the force which is applied on the spring, then it's come to the it's considered a particular length, which can we say that is a particular we can say that is a zero length. And the advantage of zero length is that we can increase the time period of the gravimeter. So this is the complete picture of the gravimeter, I think. हाँ सुदीप, आई थिंक यही था, वो आपकी कुछ डाउट हो तो पूछ सकते.
So, Pawan, which one type of gravimeter is more sensitive, stable or unstable, and why?
अनस्टेबल.
And why?
बिकॉज अनस्टेबल अपन ने यूज किया कि एक एक्सटर्नल फोर्स है, वो जो सिस्टम को ना स्टेबल की तरफ नहीं मूव कर रहा था. जैसे उसमें कुछ चेंज हुआ, डेंसिटी में कुछ चेंज हुआ या वेरिएशन हुआ, तो क्या क्या करेगा, उसमें तुरंत उसका वो मेजरमेंट कर लेगा.
Why we are calling it unstable?
हाँ हाँ, ये मतलब अनस्टेबल अपन बोल रहे हैं कि वो जो सिस्टम, जो जैसे अपन बात करें सिस्टम को उसके इक्विलिब्रियम पोजीशन से थोड़ा डेविएट किया, तो वो उस सिस्टम के पास नहीं आएगा. जैसे अपन एक्सटर्नल फोर्स को रिमूव कर दिया, तो वो उस सिस्टम के पास नहीं आएगा, क्योंकि अपन ने एक एक्सटर्नल फोर्स पे अप्लाई किया, नेगेटिव फोर्स, विच इज अनस्टेबल टाइप.
And what is the order of sensitivity in the unstable type gravimeter?
अनस्टेबल टाइप ग्रेविमेटर 0.01 वो मिलीगेल.
Okay, Pawan, thank you.
एनीवन?
Pawan,
Yes.
which gravimeter is more sensitive, Lacoste or Orden?
In both Lacoste and Boden, ये Lacoste more sensitive.
Acha, and you mentioned some advantages of using Orden. Can you repeat it? What are the advantages?
वोडन जो ग्रेविमेटर वो थोड़ा क्या होता है कि लाइट होता है, इसको ना थोड़ा अपन इजीली ट्रेवलिंग भी कर पाते हैं. दूसरी बात ये कि अपन ने क्या किया, एक पर्टिकुलर पॉइंट पे मेजरमेंट किया, तो उसको मतलब ऑफ करने की जरूरत नहीं है कि दूसरे स्टेशन पे अपन को लेके मतलब उसको उठा के लेके जा सकते हैं, उसी को मतलब ऑफ करने की जरूरत नहीं है इंस्ट्रूमेंट को. बट लाकोस्ट को थोड़ा हैवी होता है उसका इन कंपेयर. तो यदि अपन एक पर्टिकुलर पॉइंट पे मेजर किया ग्रेविटी, उसको ऑफ करेंगे, उसके बाद में उसको दूसरे पॉइंट पे लेके जाएंगे थोड़ा सा. और इसमें क्या है, जो टेम्परेचर का वेरिएशन होता है वो ऑटोमेटिकली कंपनसेट करता है. जैसे टेम्परेचर हाई है तो उसको जो कोल्ड कर लेगा. तो इसमें कुछ वेराइटी होते हैं वोडोमीटर में, बट यहाँ पे ना लो कॉस्ट में ऐसा कुछ ऑटोमेटिक टेम्परेचर कंपनसेशन का कुछ सिस्टम नहीं होता.
अच्छा, और एक बार ये जीरो लेंथ वाला कॉन्सेप्ट दोबारा बताओगे?
हाँ हाँ,
कि जीरो लेंथ क्या है?
जीरो लेंथ का कॉन्सेप्ट ये है कि अपन को क्या करना है कि टाइम पीरियड इंक्रीज करना है, जैसे अपन को अच्छी एक्यूरेसी मिल पाए ग्रेविटी की. तो इसमें होता क्या है, इसका मतलब ये है कि जैसे अपन क्या कि स्प्रिंग पे कंप्लीट फोर्स को अप्लाई, जो एक्सटर्नल फोर्स है उसको यदि अपन रिमूव कर देंगे, तो क्या है वो ऐसे पर्टिकुलर शेप में आ जाएगी स्प्रिंग, उसकी लेंथ ऑलमोस्ट जीरो हो जाएगी. तो इसका एडवांटेज यही है जीरो लेंथ, जितना मेरे को पता है कि मतलब सिस्टम जो उसका जो टाइम पीरियड इंक्रीज हो जाएगा. जैसे वहां पे अपन सिंपल पेंडुलम की बात करते हैं तो उसका जो टाइम पीरियड है बहुत कम होता है, बट यहाँ पे जीरो लेंथ यूज करने से क्या होगा, उसका टाइम पीरियड इंक्रीज हो जाएगा, तो उसका जो मेजरमेंट होगा वो सेंसिटिव ज्यादा हो जाएगी.
अच्छा, ठीक है।
और किसी को कुछ मतलब ये इनके बारे में बेटर पता हो तो वो वी कैन एक्सप्लेन। हाँ।
Pavan, one
यस
question.
यस यस।
What is the difference between absolute and relative measurement?
एब्सोल्यूट में अब अपन एब्सोल्यूट की बात करें तो क्या होगा कि एट ए पर्टिकुलर लोकेशन में अपन को ग्रेविटी की वैल्यू पता है, उस मतलब जहाँ पे पर्टिकुलर पॉइंट पे, जहाँ पे एक पर्टिकुलर स्टेशन पे। और रिलेटिव का मतलब क्या है कि अपन को एक पता है उसके रिलेटिव में कितना चेंज हो रहा है ग्रेविटी। जैसे अपन एक बेस स्टेशन ले लिया, उसके रेस्पेक्ट में कितना चेंज हो रहा है ग्रेविटी, तो वो मेजर करेगा। एनीवन? ओके।
Okay, and the next topic is going to represent.
एंड अंशुदीप, विच एरियाज में थोड़ा इंप्रूवमेंट करने की जरूरत है?
प्लीज एवरीवन, अगर आपके पास कोई सजेशन है पवन के लिए तो प्लीज आप बताइए।
फ्रॉम माय साइड आई थिंक इट इज ओके पवन, तुमने अच्छे बोला एंड मतलब डिस्क्राइब भी अच्छे से किया।
हाँ पवन, सही है। जो जो बोल रहे हो और जो डिफेंड कर रहे हो, अच्छा है।
Yes, it was good. आपने डिफेंड भी बहुत अच्छा किया और आपने प्रेजेंट भी काफी अच्छा किया।
Presentation was good.
Yes, Pawan, overall presentation was good, and I have one small suggestion. अगर कि ट्राई टू बी फॉर्मल, ये अपन वर्ड जैसे कि यूज करते हैं हम कॉमन आपस में कर रहे हैं वो तो जानता हूँ, बट ट्राई टू यहाँ ना वो वर्ड यूज करो ताकि आप एक मतलब फ्लुएंसी रहे आपकी, वहां का यूज होता है तो वो इट विल लुक लाइक द इट इज इनफॉर्मल, है ना। कॉमन में कर सब यूज करते हैं, सभी को पता है, बट वो इनफॉर्मल थोड़ा सेंस करता है क्योंकि एक दिन में तो बदला नहीं जाता कुछ भी। सो
यस।
बाकी ओवरऑल इज गुड। बस वही है, पॉइंट यही है कि जो आप दे रहे हो वो डिलीवर्ड हम तक हो रहा है, तो यही पॉइंट होना चाहिए।
थैंक यू।
ओके, सो नेक्स्ट टॉपिक इज आई थिंक गौरी इज गोइंग टू रिप्रेजेंट। हाँ,
शानू का तो बेसिक्स था शायद।
हाँ मेरा बेसिक था।
so
मैंने
if you want to if you have prepared then you can.
ओके मैं थोड़ा बहुत करता हूँ। ओके 1 मिनट। Okay, so gravity method. So gravity is a fundamental force of interaction, so which cause the mutual attraction between the all the mass and energy. So and gravity is a potential field, means that gravity, whatever the force, is proportional to 1/r square. And the gravity method, it is a passive method, hence the no energy is required for acquiring data. So when we are acquiring the data, we have no need to external any energy source. And gravity is a simple field, means it is unipolar, and so that's why it is simple, and we no need to be um, no need to be focus on the much complicated the dipole term or another term. So it is unipolar. We have the advantage of the gravitational field. And next is the why we are using the gravity method. So gravity method we are using because the to study the subsurface geology. Okay, so variation in density of the subsurface rock will produce the gravity anomaly. if we are if in a subsurface there is a density variation, then it will produce the in a as the Newton's formula of the gravity. So the gravity is proportional to the mass, and mass is proportional to the density. So if density is vary, then gravity will also vary. And when the rock the below the subsurface are dense and heavy, so there is a extra gravitational attraction which increase the downpull of the gravitational instrument and create a positive gravity anomaly. So that's is the motto our for the using the gravity instrument. And now the most important concept is the gravitational potential. So gravitational potential, it is the means when a unit mass, we bring a unit mass from an infinity to at a point. So whatever we are required to work done or energy to bring that mass from infinity to that point, it is the gravitational potential. Now from this, that concept came that equipotential surface. So equipotential surface, it is the surface where the potential is the constant. So no need to work to be done from moving one point to another point. So that it is the equipotential surface, and the force and acceleration acting perpendicular direction to the equipotential surface. And these equipotentials, so we have the two type of equipotential. One is the physical equipotential, means what is the actual means true distribution of the mass of the earth inside the earth. So that is the whatever called equipotential. So this is called the geode, which reflect the true mass distribution of the earth. And another thing is the mathematical. So we are calculating in taking the average density of the earth, and we are calculating the from the Gauss distribution formula, and whatever the came, and it is the mathematical reference. So it is a mathematical surface of equipotential of the earth, and the geode is the true means it is the actual of the equipotential, actual the earth equipotential. And why we are calculating the both, because that this difference whatever we are got from mathematical and whatever we are seeing that in a physically. So this difference, if we got any difference, then we can calculate that there is an anomaly, gravity anomaly, and there is some material, probable material is there. So these are the interest to knowing that both mathematical and the physical. And this, so that much from my side. If you have any question, can ask. Hello, am I audible?
Yes, Anu. I have one question.
Okay.
Is the gravity field a conservative field?
Yes, gravity is conservative.
So, what do you understand by the conservative field?
Conservative fields means it is the mathematical, it is the curl is 0. Means conservative means if we are put work done in a physical, and we would actually I'm lost my word.
So, okay. So,
It is a
what is
conservative field.
okay? It is the conservative field. Okay. So, what is its value? Value of the gravitational acceleration?
So it is 9.8 meter per second square something. It's means it is not too precise, but we are when we are calculating it, we are calculating a precise value.
What is its unit in the geophysics? Generally, in which unit we measure it?
Actually, we are measuring that in milligal. So milligal, so 1 gal is the 1 semi per second square. Actually, we are measuring in difference in milligal. So 10 to the power minus 3 cm per second square we are measuring.
Does it vary with the
As a conservative
height?
field also means whatever a conservative field means it is path independent, and it's we can represent it in a scale gradient of a scalar form.
Okay, okay. So does it vary with the height or the elevation and
Yes,
how?
it is very means it is proportional to 1 by, I think it's proportional to height 2h by r something. No? So we that's why we did the correction of the gravitational correction for the elevation. So it's proportional to height. No, I think that it's very means the difference in gravity. It is
So value of gravity is at which point is high, at the pole or at the equator, and why?
no, it is high at the pole, and equator it is the less. So actually, because there is means in a pole we have the means Earth is rotating, so due to the its rotation, so there is centrifugal force also, so which act as a outward to the radius, so it will decrease the gravitational field, and but in a pole region it is not present, so that's why pole increase. And another thing also effect is the earth bulging, the spheroid earth. So in equatorial region there is a more mass than the polar region. Polar region is the flat. So these two term will, that's why that polar region is little bit higher than the equatorial region.
So have we heard the term polar flattening? How will you define
Polar
it?
flattening.
Hmm.
Yes, polar flattening means Earth is not a truly spheroid. So polar region. So if we are measuring the radius, so in equatorial radius it is I think that 6378 I think, and in polar region it is 6357 km. So there is a difference in a radius in polar region and the equatorial region, and that's why we are called the polar region is more flat than the equatorial region. So that's why the polar flattening, and it is region also Earth as a Earth rotating. So due to the centrifugal force, so the mass will gather at its orbital axis, equator region at the equatorial region, and that's why we call the bulging effect also, and the polar region is getting flat.
And what is the geopotential?
What is the
Geopotential. The
geopotential
geopotential of gravity. Yes.
means what you are asking, that geode and spheroid concept.
No, no, no. Geopotential. The geopotential in the gravity.
Geopotential.
Like we have the scalar gravitational potential. So there is a
uh,
term, geopotential, the potential of gravity. Do you know about it?
no, I'm not getting your point. What is the answer?
So geopotential is the combination of the gravitational potential plus the centrifugal potential due to the rotation of the Earth.
Okay, okay.
So it is the if we I define the UG as a gravitational potential, then centrifugal potential is minus k half omega square r square sin square theta, where theta is the co-latitude, omega is the
Yes.
angular velocity of the Earth, and r is the distance of a point from the center of Earth. Okay. Thank you.
Okay. Okay. Any question?
Sanu, from where do we adopted the shape of the earth?
Where to adopt?
हाँ, shape of the earth हमने कहाँ से adopt किया है?
Mhm. Means we are measuring now from the satellite view and all these things that there is a
There is a
difference in.
certain reference system from where we have adopted it.
Means for mathematical calculation
See, I'm
or
talking about the shape that we are saying that the Earth shape is oblate spheroid. So from where do
yes,
we
yes.
have adopted it?
Means so it's spheroid concept, no? The where the mathematical surface we are
Yes,
calculating the equivalential surface. So for that equation we are using the oblate spheroid concept.
there is a certain name to that reference system.
No, I'm not getting what is answer.
It's a geodetic reference system.
Okay, okay.
सानू कोरलेस also कोरेज जो फोर्स है वो also affect the shape of the earth or not?
Yes, it also affects the shape of the earth
And also affect the change of the gravity.
because means there is a correlative effect. So there is a mass distribution depend on the correlative effect because when the plate tectonic is means plate are moving, its effect also correlative force. So mass distribution is depend on the correlative effect. As a direct, there is no relation.
And okay, and if you
Direct, no, 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 no. One thing, no, no, direct also means we did direct also relation. No, I'm confused. Anyone know? I think gravity is depend on correlative effect also.
ओके एंड कोरलेस फोर्स है ना वो नॉर्थ नॉर्थ साइड जब अब यदि आप नॉर्थ पे हो नॉर्थ से इसकी तरफ जा
Mhm.
रही है तो कोरलेस फोर्स का इफेक्ट किस तरफ किस डायरेक्शन में होगा if you throw a particle through north to south then what is the direction of Coriolis force which is affect the path of the particle?
Actually, it is no, in a north hemisphere. It's in a left-handed. Means if we are going from which direction? East.
आप नॉर्थ से साउथ की तरफ जा रहे हो तो वहां पे कोरलेस फोर्स का इफेक्ट किस डायरेक्शन
No.
में होगा?
So it will be east direction. I think it's a left. It's work on the left. I mean, in north hemisphere it is left side, and it right. And southern hemisphere it is right.
यस यस यस
So force effect on.
वेस्ट डायरेक्शन में राइट साइड में हाँ ओके
Okay, any question?
What are the applications of gravity methods?
So gravity method application. Gravity we are means main aim our for the gravitational survey to know the subsurface geology. So to for the mineral, if there is any mineral in the subsurface, so there will be in a density contrast in there. So gravity will help us to know that the contrast in a subsurface, and so for that purpose only we are using the gravity survey. Also, it's used in a seismic means seismic active area. So there is also mass density difference. So from the prediction of the earthquake, also we can use the gravity survey, and to archaeological evidence also we are found from the gravity survey. Any
Anyone?
question?
अमृता, गौरी,
नहीं ठीक है.
आज्ञा, विमल.
Yes, I have one question. Am I audible?
Oh, yes, yes.
Yes, yes.
तो मैं पूछ रहा था, what is the difference between Coriolis acceleration and Eötvös acceleration? What is the difference between the two accelerators? Eötvös and Coriolis. What is the difference between the two types of accelerators?
I think Eötvös is produced because of the Coriolis effect, no?
No. I mean, actually, whenever a body is moving, okay, whenever a body is moving, then there are two components of the velocity, right? One is horizontal and one is vertical. Okay, so the Coriolis acceleration is due to the horizontal motion. Okay, so if a body is moving, in the horizontal direction, like then the Coriolis acceleration will act. Okay, I mean,
yes. But it was
no, wait.
No. Because it's come.
No, I am just saying the opposite thing. I think. Look, when the body is moving north or south, okay, vertical. Okay, there are two components of the velocity, vertical component and the horizontal component. Okay, so when the body is moving, so when we take into account of the vertical component, okay, then Coriolis force acts. Okay, Coriolis acceleration is taking place. Okay, and when we take into consideration about the horizontal component of the velocity, then the Eötvös acceleration takes place. Okay, so the effect is that in case of Coriolis acceleration, the body moves in the right or left direction. Okay, if you use this cross vector product, okay, because this is given by omega cross r, right? So if we use the cross product, then we find
velocity.
What?
Coriolis effect is minus 2m omega cross v, I think.
Yes. I mean, yes. So it is. Yeah. What is the cross product? I mean, omega cross r, something like that, right? What is the formula?
Means, means omega cross r means omega cross v, means you can velocity also that.
तो मैं वही बोल रहा हूँ, ओमेगा क्रॉस v का यदि हम ये क्रॉस प्रोडक्ट लेंगे तो कोरियोलिस एक्सेलरेशन का जो डायरेक्शन है वो राइट या लेफ्ट में होगा. ठीक है, नॉर्दर्न हेमिस्फीयर में राइट की तरफ होगा और साउदर्न हेमिस्फीयर में लेफ्ट की तरफ होगा. ठीक है, उस तरह से Eötvös एक्सेलरेशन के केस में क्या होगा कि बॉडी जो है हम यहाँ पर हॉरिजॉन्टल कंपोनेंट को लेंगे. ओके, सो when we take the horizontal component of the motion, then the Eötvös acceleration would be either downwards or upwards. Okay, so that is going to affect the measurement of gravity. Okay, so Eötvös acceleration affects the measurement of gravity, but Coriolis acceleration is not affecting the measurement of gravity, but we use it in it has many roles, like it deflects the wind. Okay, then inside the Earth's core, it plays a very important role in generation of magnetic field. So all these applications there are of Coriolis acceleration. Okay. This is the whole idea of Coriolis acceleration and Eötvös acceleration. Did you get it?
Okay, yes, got it.
Yeah.
Means if it is not vertical to the surface, then means it will not means considered in the gravity partner. Because
yes, I mean whenever a body is moving, okay, wherever, then both forces will act, both acceleration will act. Okay, but for gravity measurement, we have to take into consideration only of the Eötvös acceleration. Okay, because because here the force is acting upwards or downwards, and gravity is always downwards, right? So that's why we always take into consideration of the Eötvös acceleration, not Coriolis acceleration. That is
okay. Thank you, Vimal.
Okay, thank you.
Any other question?
Okay.
Yes. Why is Earth not a perfect sphere?
Why Earth is not a perfect sphere? So this is also means its effect on the both the means
Yes.
centrifugal force. One of the reason
Yes. Yes. This is
Earth is
this is only due to rotation. Okay. Yeah.
rotation. Yes.
Yeah. Rotation, and from rotation this is
Also,
centrifugal. Uh,
uh, also means other terrestrial body also means like moon, sun also effect.
हाँ
Gravitational
वो
pull
भी
also
कारण
one
है,
of the
ग्रेविटेशनल अट्रैक्शन जो होता है सन और मून की तरफ, हाँ वो भी एक कारण है, हाँ वो दोनों।
yes.
ठीक।
Okay, Sanu, I think anyone want to ask the question? Any question? Okay, now Gori, you can go for the interpretation part of the anomaly.
No, I'm not doing interpretation. I'm doing field surveys.
Uh,
Field survey.
okay, you can go for it. Okay, you can start.
Okay, actually, mm, gravity field survey is basically carried out in land and in sea. Although there have been attempts to measure it through airborne ways, it is not that efficient. When coming to the land surveys, the main aspect is that the range of gravity stations, the spacing of the gravity stations will be of uh, the range 20 kilometers to 5 meters, and it varies according to the need of the survey. In oil exploration, we will have a space station spacing of the range 2 to 4 kilometers, which is smaller than the structure associated with the oil accumulation, so that we will get all the anomalies associated with it. So that is, no anomalies will be missed in that case. In some cases, like in petroleum surveys, we will use uniform grids search within a loop with a range of 6 cross 6 kilometer square area. And in mineral exploration, gravity method is used as a secondary source for the confirmation or further analysis of the anomalies that have already detected by other techniques like magnetic survey and electric survey, like that. And in land surveys, we use it is used in microgravity engineering and in archaeological surveys, where we search for cavities within the earth, and also in search for bedrocks. We will choose a spacing of stations of the range 1 meter. Every time when we measure uh, gravity, the gravimeter has to be leveled precisely for at each time of reading. And in some cases, it will be difficult to get the stable null point in the gravimeter, like when we are placing it in a swampy area or in areas where it is having heavy wind, like that. To attain the one main aspect is that to attain a good precision in land survey, which is of the range such that having a elevation difference of 10 meter or 30 meter latitude variation, like that, so that we will get a good accuracy in land survey. um, and precision is an important matter, and most of the cost spent in land survey is delivered for the location and elevation determination. And an important method used for lowering the cost of this determination of location and location is that a use of inertial navigation technique. It is a method used to sense the acceleration using a three orthogonal accelerometer, which will be mounted on the instrument in a gyroscopically stabilized platform. And what it will determine is that the relative position changes, horizontal and vertical position changes of um, the instrument by integrating this acceleration over time. And next error that we will be facing with a measurement in land survey is the drift. Not only in land survey, in measurement is the drift correction. It is a variation of the null value detection, null value of the gravimeter with the time. It is occurring due to the inelastic behavior of the spring and also due to some tidal effects. And these are all about land surveys. And coming to marine survey, gravity can be measured at discrete locations in the sea using a land gravimeter housed in a waterproof container, and we used to lower it to the ground using remote operation and level it properly and read the gravity value. And the demerit of this process of using the land gravimeter is that we need to it is slow, such that we need to uplift the gravimeter each time for measuring the value of gravity and to lower it again to the sea floor, and this makes the process slow. And other process is that when there is a huge tidal currents, each time we need while using ship we need to anchor the ship each time of measurement. These all factors makes the process slow. So an alternative method in marine survey is the continuous measurement of gravity, and it is um, uh, using a shipborne gravimeter, um, which will move along with the ship. And but in comparison to the land gravimeter, the accuracy of the marine shipborne gravimeter will be less due to the vertical and horizontal accelerations of the meter due to the movement of ship and sea waves. And the horizontal acceleration, and which will affect the gravimeter reading, can be avoided by placing the gravimeter in a gyro stabilized horizontal platform, so that the meter will only have an effect of vertical acceleration, and vertical acceleration effect of gravity we cannot detect it easily. And to avoid this error due to the vertical acceleration of the meter, we used to average out the value for an interval of time, so that it will nullify the upward and downward accelerations to the meter. Then and there is an effect also due to the cross coupling. It is an effect in the error occurring in the shipborne gravimeter associated with the beam supported mass system instruments like Lacoste and Romberg instrument, which is caused due to the simultaneous effect of horizontal and vertical acceleration of the ship meter. And another major error in shipborne measurement is the Ito's correction. It is a variation of the gravity reading measurement by gravity reading measured by the gravimeter when it is having a velocity. This is due to the variation of the centrifugal force acting on the meter from that it is in rest. That is when an eastward component of velocity is acted on the meter, it will add up with the velocity owing to the rotation of the earth, and this increases the centrifugal force and thereby decreases the gravity reading. And similarly, a westward component have an opposite effect, and it decreases the centrifugal force and increases the gravity reading. And northward and southward component too will have an effect. It will be vectorially added to the centrifugal force acting, and it will also have an effect on the gravity reading. When coming to airborne survey, it is the most complex method of field survey because it is prone to so much of errors. The main error is that it is suffering is ethos correction, and even 1% of error in the velocity of a heading of the meter will cause a huge change in the gravimeter reading. And it is also affected by the altitude variation, linear acceleration, and heading, etc. On the aircraft. And this is much more than what we are experiencing in shipborne surveys. Now I am going to explain few applications of gravity survey. First one is in mineral exploration. It is used to search and discover the ore bodies within the earth. And secondly, it is also used to find out the boundary of the ore body and to find out the weight of the or tonnage of ore bodies at a place. And in this case, for a good measurement of these values, it is depending on the station spacing and the sensitivity of the gravimeter. And it is also used in engineering field for site inspections to determine the extent of the disturbed areas where we cannot use other geophysical methods due to the electrical and other noises, and or due to the presence of other public utilities like pipes and all. And third application of gravity method is to detect the cavities within the earth, and it is used in engineering and hydrological surveys. And other is the detection of massive ice in the permafrost terrain. The melting of ice in the permafrost area will cause several engineering and environmental problems, and to avoid this we need to detect it earlierly. So there's large bodies of ice within the between the layers of earth will create a great gravitational anomaly, and this can be detected in that way. And it is also used in archaeological investigations where we can use microgravity technique to understand the crypts and passages in the excavation works. Other application. Gravity method is also used in hydrological um, hydrogeology, and it is less used when compared to electrical techniques, but it is also used to identify low density um, rock parts which can be an aquifer which stores the water, and it can also thereby locate and detect the variation in the water content within the beds. Another application is detection of volcanic hazards. Um, it is possible to detect using a very sensitive gravimeter to um, understand the elevation of the magma within an active volcano. Uh, these are all some of the applications. That's all. Hello.
Yes, Korea. I have one question.
Yeah.
So, what are the limitations for the gravity method?
The limitation is that it is not possible to accurately determine the unique solution of an anomaly.
And any other?
No, I don't know.
So, it has the problem of the no uniqueness, and also this method is slow due to because it requires the contact with the
Yeah.
object. So, if anyone has no other limitation, you can please.
असुदीप क्या बोला आपने आंसर?
There is the there are mainly two limitations. One is the problem of the non-uniqueness. Because different density contrast can lead to the same gravity anomaly. So एक बहुत सारी चीजें भी सेम चीजें रिजल्ट दे सकती हैं. एक तो वो प्रॉब्लम ऑफ द नॉन यूनिकनेस होगी, यूनिक नहीं है अपने आप में, जरूरी नहीं है कि जो हम चाह रहे हैं वही है. एंड सेकंड इज द इट इज दिस मेथड इज स्लो because it requires the contact. Gravimeter required the contact with the surface.
Okay, okay. Thank you.
In mostly. So
Sensitive also now it's made a very highly sensitive instrument. Sensitivity also. Maybe means sensitive also one of the limitation also now means we require a very highly sensitive instrument.
Yeah.
And we need to correct every time, each and every time.
Yeah. That will especially the one thing that makes the marine survey so slow if we are using the land gravimeter.
Yes.
Okay, Gauri, I have one question. Uh, Let us consider two survey situation, one at ground and one using airborne. You are measuring the gravity data at ground, and at the same location you are measuring using airborne. So how these two data should differ and why theoretically?
Theoretically, it will vary due to different corrections. The station height is different now. So it can cause the correction, different sort of correction like free air correction, like that. Is that what you meant?
Actually, I was also wanting the same answer because the height difference is there obviously, and also the velocity consideration, adverse correction you just mentioned, the
Yeah, yeah.
gravimeter is suffering. And uh, if we just consider that the survey location is not so high, not at so much height, then these two values should same. Upward continuation concept was also probably same, using this same concept that we are measuring density at ground. Due to the same mass distribution, we are measuring the value from airborne, as there is no masses in between these two locations. So just simply continuing the concept upward, using the upward continuation, we can measure the gravity value. So using the theoretical gravity value and measured value, we can also calculate the anomaly from that concept.
Yeah.
So okay, okay. I think anybody if have any question.
Uh, just for the information, Gauri, which is the most important application of the gravity method?
I think it will be in oil exploration and also in cavity detection. This too, I think.
Okay, okay. Thank you.
So the next topic will be probably interpretation, and Ashudeep and probably on me, the responsibilities are there. Last day, Ashudeep explained the topic. Is there any other topic left?
Yeah, I think we have completed most of the topics. This is the last one.
So you will explain, or should I?
If you want, you can please continue.
Oh, okay. So last day also we have explained about the interpretation portion, and we have the gravity field data. It at any location we want to measure, we have field data. We have corrected the datas, and we now have the anomaly value at the survey location. So we want to interpret what are the possible reasons or sources of those anomalies. And for that, we can classify those type of anomaly in mainly two types. One is regional anomaly and another is residual anomaly. Regional anomalies are basically those anomalies which are caused by deep lying object. Basically using it is dependent on those natural phenomena, subduction zone phenomena or converging plate sorry, diverging plate phenomena. Those concepts are related with regional or deep line object, and according to our exploration perspective, normally residual anomalies are important, which are which are due to shallow lying objects. So the primary objective is to process these two datas and to differentiate between these two datas, that which one is coming for shallow lying object and which one for deep lying object. For that, after the we have the corrected datas, we will process the data, and there are several techniques for processing to separate out this regional portion, and according to our objective, we can obtain the residual data or regional data. So some procedures are to identify or to separate out these two datas are just simply by visual analysis. Normally the residual anomalies show complex contour or complex variation, whereas the regional variations are comparatively smoother in nature. So some techniques are there. One is visual analysis, Second is polynomial representation. We try to formulate a mathematical model to correctly depict the regional portion, residual portions, and to subtract those datas from the obtained field data. Then is frequency filtering. Because of deep lying object, those are normally longer wavelength phenomena. So regional anomalies are due to comparatively larger wavelength. So using frequency filtering, that is, if we apply low pass filter, then it will consist only low frequency portion. Low frequency means longer wavelength. So this frequency filtering technique can be used to separate out also. So these are the possible methods we can use to separate out our required anomaly value. Then we try to know what are the possible sources or possible reasons that may be there that are responsible for those anomalies. And one is direct interpretation, another one is indirect interpretation. Direct interpretation, I think actually what we are doing, we have different simple models and we know how the anomaly will arise for those cases. So we simply try to find that if there is what are these simple models. We can consider sphere, we can consider horizontal cylinder, vertical cylinder, any horizontal line element. So we try to understand what are the possible anomaly curve that may be responsible, or what are the possible sources. This is direct interpretation. And indirect, what we do, we try to model, we try to provide different density values. Actually these two are interdependent. We normally shape the gravity anomaly value is shape independent. So in most cases, considering the simpler gravity model, we can have the actual anomaly curve. In this way, we try to find out that what are the possible reasons, possible structures inside the subsurface. So there, the questions may arise that if there is some anticlined structure or synclined structure, how should be the anomaly curve? So for that, we consider horizontal cylinder and we try to analyze that if the anomaly curve is somewhat similar to this, then we can say there may be some anticline or syncline structure. These structures are important, particularly anticline structures for oil and gas exploration purpose. Then the case arise, may any spherical body is there within the subsurface. For that, we have an anomaly graph. We can compare this model with salt dome or any type of diapit structures. Some intrusion is occurring within the host rock. So from that, we can understand that probably salt dome or any type of uh, intrusions is there. Why a salt dome is also important from the oil and natural gas perspective, because there is a it is a possible hydrocarbon trap. Then how we can understand any fault structure is there or not. This also can be uh, compared with the simple structure of a line element, horizontal line element. So this is the basically reason why we do interpretation. We try to understand what are the possible reasons and how they are important with our field survey. These sort structures have significance, and we try iterative methods that what are the possible density density contrast, or what are possible depth these we can try to analyze. And as it is already known to all that gravity method is non-unique, it will not provide any unique solution that for this configuration or this particular uh, arrangement this may arise. So this suffers from non-unique problem, but something is better than nothing. So we try to analyze the possible sources or possible structures within the subsurface. This is what we try to uh, interpret using the gravity data. And I think this is from my side. If Ashudip wants to add anything, he can, or you all can ask questions.
Yes, I want to add something. So just, just give me 1 minute.
Okay. If you have any questions, anybody else, then you can ask. Within that time, he can search also.
Amrita, I have one question. What is
Okay.
the gravity profile and gravity map?
Gravity profile means we are having the anomaly curve for the variation in uh, at a particular location. We are measuring the gravity value, and we are trying to plot it in graph page. Then probably this is anomaly curve. And mapping, it is a contour mapping, probably 3D representations of the anomaly curve. I think this is the difference. One
Anyone?
is, oh, okay.
Okay, you can continue. Please continue.
No, I was just saying that we have the anomaly value and we know the locations of our survey. So we are plotting these two datas in any graph page or any graphical method. So we are having our anomaly graph with our locations. And in another case, we are traversing in two directions. Just we are considering in XY plane we are going. So that representation can't be placed in a single X or XY curve. So for those cases, we prefer the contour representation of graph, that where we are getting possibility of any anomalous zone there. Depending on the control location, it can actually give us information that here is a possibility we can have those anomalous density distribution. I think if anybody know anything else, then they can say.
Anyone who knows more about the gravity profile and gravity map? Bimal,
Yeah, I have a question. I don't know the answer. How do we use gravity method in oil exploration? Yeah, hello.
Actually, it
Hmm.
let me give the answer. As I
Yeah.
have mentioned, all those concept, actually in interpreting, we are considering simpler models like sphere or horizontal cylinder. We
Yes.
simply we can't say that there will be probability that we can have oil, surely, but we can actually say that whether there is any possible structures present there where an oil can accumulate. Like in salt dome, oil can accumulate. In fault, oil can accumulate. Also in anticline structures, oil prefer to accumulate all those regions. So in those cases, we can say that gravity method helps us to find the structures where actually oils are accumulating.
Okay. Thank you. Thank you.
Okay.
So, up to my best knowledge, gravity profile. So during the measurement, we have to follow the particular line. So at a one point, as we have taken the reading, so we will go for the next reading. So we generally follow a line during the measurement, and that gravity profile is the line of the measurement during the observations. So it is the 1D line. और gravity profile map जो है, it is getting after the we will get after the observations in the from the reading data. So that's this is that I know. Okay, so I want to further extend the discussion of the interpretation part. So as Amita said, the we have the gravity anomalies, basically the combination of the regional and the local, that is residual gravity anomaly. So just we want to break the gravity anomaly into its constituent parts, that is the residual and the local anomaly. So we just want to break down these anomalies so that we can better understand the anomaly. So there are a few methods to uh, break the gravity anomaly into its constituent parts. So first method is the visual method. So we will it is the simplest method to represent a regional gravity anomaly on the gravity profile, just by the visually fitting the large scale tent with the smooth curve. So what we will do, we will take the observation at one point, point by point, and we will generate bus uh, uh, or connect the all the points with the smooth graphs. So it is the simplest method, or it बस it method की कुछ certain problems है, like this method depends on the experience and skill of the observer. If you are good geophysicist, good, you have the good experience of this, then you can do it. Otherwise कोई नो से क्या करेगा तो error आनी है. So then okay, so then further to improve this method, we have the polynomial fitting method. So now we will represent the regional gravity anomaly by the smooth polynomial curve. For example, straight line and further curve. So the polynomial fitted by the method of the least square fitting. So in the mathematical physics, you can go for the what is the least square fitting. So just for the hint, so we will write the any function as the higher order of the suppose polynomial, the function is the g is the function of the x is where the distance, horizontal position on the gravity profile. So we will write this function as the gravity anomaly. Z is equal to some z naught plus z1 x plus z2 x and plus dot dot dot. So for the better smoothing the curve by the mathematical process, we will use this method. And further, there are Fourier series analysis method, where we will assume the gravity anomaly variation is periodic with the position. So we can use the Fourier series method, because in the Fourier series, if any function is the periodic function of the variable, then we can write that function into the sine or the cosine some in the sine of the sine and cosine combination. That is, any function can be written as the sum of the series of the discrete harmonics, where discrete harmonics are the sine that may be sine or the cosine with the particular argument. So Fourier series के बारे में questions that can be asked: what is Fourier series and how we can write any function? What is the condition? So condition is that if any function is the periodic in with the variable, there can be position or time and thing. So and the last method is the Fourier transform analysis. So the geophysical signals are not periodic in actual and best be represented by the continuous spectrum of the wavelength. So in reality, the geophysical the anomaly real in the practical the geophysical anomaly is not periodic with the position. So to represent the anomaly function, we can use the now the Fourier transform. So any function can be represented by the Fourier transform. So we are using it. And the for the question on this topic can be asked what is the Fourier transform? Uh, how many type of Fourier transform do you know? Sorry, not Fourier transform. How many type of transform do you know? So where are we are using these transform? And what is the again the in the Fourier transform what we'll do in the Fourier transform we can write any function as the in the different coordinate system, not the coordinate in the different variable. For example, the time, if we are in the time domain, then we can write any function in the frequency domain. So if it is time t, then frequency domain will be the 1 by t. So this also called the Fourier integral. So Fourier integral, it consists continuous set of the frequencies instead of the discrete set, and it can be used for the periodic and the non-periodic functions, and that's why we are using it. So okay, now okay, so um, that much is I think sufficient for the this one. Thank you. Any question?
Okay, you explained about the processing part, so it was nice. I would like to know in what cases we will use a Fourier transform, and what is the basic difference between Fourier series and Fourier transform?
So as I said, they are the some methods which we are using from the initial period, and now in the modern time we are using the Fourier transform by the computation. So the visual methods, as I said, it has a limitation because it depends on the experience and skill of the observer. Next method we have the polynomial. Again, it has the mathematical difficulty. It will take time consuming. So the next is the Fourier series and the Fourier transform. So if any function is the periodic in time or position or whatever, if we are writing in the function, then that function can be represented as the combination of the sine or the cosine. So in the Fourier series, if you want to write any function as the Fourier series, it must be periodic function. But in reality, gravity anomaly is not periodic with position. So we cannot write the gravity anomaly with the in the Fourier series. So Fourier transform, we can write any function as the integration. Suppose I want to write the function fx. The Fourier transform of the fx will be the integration fx e to the power uh, sine I data sine t और dt something. तो ये इस तरह हम लिख सकते हैं इसे. So Fourier transform, if it is a function periodic or non-periodic, you can write the Fourier transform of any function. But in the Fourier series, the function has to be periodic uh, function.
Okay. Any other question?
कन्वोल्यूशन भी मैं बता देता हूँ. ओके ओके विमल प्लीज आस्क क्वेश्चन.
Yeah, how do we use Fourier transform in separating the regional anomaly and the residual anomalies? I mean, how do we use it? How can we, by transforming a particular function, I mean, gravity anomaly function into frequency domain, How can we separate it? I mean, I'm not getting it. Are you getting me?
Yes, yes, I have. I got your question.
Okay. Do you have any idea?
Actually, it can be best represented by the graph. Actually, I don't have the hand presentation, but if you go into the Lori book and mm, we will have the graph, a zigzag graph of any anomaly. Then, for example, just I these methods, um, we are just uh, we are just representing any curve in the mathematical form by these graph, by these all these methods. But for the separation, we can do it is the complex process. So, and actually, I do not know more about it.
We can
So,
use filtering. I mean, low pass filter and high pass filter to separate the noise, right? I mean, regional anomaly from residual anomaly, right?
yes, yes,
The,
yes. It is the
the
convolution
filtering
and
method.
the process of the deconvolution. Yes,
Okay.
we can use the filter function on the observed Getty anomaly function. So from these methods, we will get the gravity anomaly function in the form of the mathematical form sum. Then we will apply the filtered function. So filter function uh, can be the we can choose as much as we want key which frequency we want to eliminate from the function. So, for example, the extent of the anomaly graph represent the wavelength, है ना?
Yes.
So, and frequencies again the frequency is the inversely proportional to. So, वहां से किस frequency का हमें eliminate करना है, it can be done through the filter function in the frequency zone or in the time frequency zone में generally हम करते हैं इसे. So we have the two type of functions, low pass filter and the high pass filter. So low pass filter are designed to pass the frequency shorter than a selected frequency. So it will if we have the low pass filter, so it will pass the all the frequencies. Suppose मैंने 50 hertz इतनी frequency ली कोई, then it will pass all the frequencies below the 50 frequencies and eliminate all the frequencies above the 50 hertz. And the low pass filter in the gap method is used to study the regional anomalies. So because regional anomalies has the larger wavelength, that is larger extent of the anomaly curve, and the where the high pass filter are allowed to pass the high frequency, the frequency that are longer than the selected frequency and eliminate the shorter frequency. And the high pass filter are used to study the regional anomalies. So using the filter function, all this process is known as the convolution, means process of multiplying the filter function with the observed gravity anomaly functions to get out the filtered function. So this is a convolution, and deconvolution means we will get the original function from the combination of the filtered and the original function. Did you get it?
Yes. So we use deconvolution or convolution.
We use the convolution in the starting.
I mean, we have the gravity data, right? And
Okay,
we
okay.
have a filtered function,
Hmm.
right? So
Okay,
what will we use? Convolution or deconvolution?
okay. So initially we will do the convolution. Suppose convolution. Now we will do the suppose we have the gravity an observed gravity function. Then we will we will apply the filter function onto it. It is this process is known as the convolution. Suppose it is in the spatial domain, that is in the x or y or the position domain. But it has a certain problems because spatial domain is the time consuming. So we will use the Fourier domain for the faster computing. So we will transform our uh, observed gravity function into the frequency domain or in the Fourier transform domain and the filter function also. Then we will again do the convolution process. So we will get the our filtered function. So we are doing the convolution process, and if we want to get the again back our function in the spatial domain, we can go for the reverse Fourier transform.
Okay, thank you.
Anything you want to add, please, you can add.
No, I haven't studied this signal processing. I think we should have a separate session on this topic, because this is very important also and a bit confusing also, right?
Yes, yes, yes.
I think we should have one session at least on this topic, signal
Okay,
processing. How
I
do we
will
use
use
it?
the informal language so for the better understanding. Suppose हमारे पास फंक्शन है, सो हमें क्या जो ऑब्जर्व फंक्शन हमें मिला हुआ है अभी, उसमें क्या करेंगे, हम उसे फिल्टर्ड फंक्शन अप्लाई करेंगे बिकॉज हमें तो अल्टीमेटली हम इंटरेस्टेड किस में है, अल्टीमेटली हम लोकल एनोमलीज में इंटरेस्टेड हैं. सो हम हाई पास फिल्टर लगाएंगे. उससे क्या होगा हाई पास फिल्टर से कि जो लो फ्रिक्वेंसी का डेटा है वो सब रिमूव हो जाएगा. मीन्स जो कंट्रीब्यूशन डीप बॉडीज की वजह से बरीड बॉडीज की वजह से होगा, डीप बरीड बॉडीज ही तो रीजनल एनोमली प्रोड्यूस करती हैं, वो वाला पार्ट हम सेपरेट कर देंगे उसमें से. तो यही प्रोसेस जो होता है, तो प्रोसेस जब हम फिल्टर फंक्शन अप्लाई करते हैं, इसी प्रोसेस को हम बोलते हैं कन्वोल्यूशन प्रोसेस. बट कन्वोल्यूशन प्रोसेस की एक प्रॉब्लम है, अगर मैं उसे स्पेशल डोमेन मतलब उसे एक्स या वाई डोमेन में अप्लाई करूंगा तो वो टाइम कंज्यूमिंग है. तो उस टाइम कंज्यूम से बचने के लिए क्या करते हैं हम उसे उसके लाइक उसके फोरियर ट्रांसफॉर्म डोमेन में जाते हैं. फॉर एग्जांपल अगर स्पेशल कोऑर्डिनेट एक्स है देन उसका ट्रांसफॉर्म फ्रीक्वेंसी डोमेन में जाएंगे. फ्रीक्वेंसी डोमेन में हम दोनों फंक्शंस को ले जाएंगे, जो हमारा ऑब्जर्व फंक्शन है और जो हमारा फिल्टर्ड फंक्शन है, दोनों को देन कन्वोल्यूशन करेंगे. कन्वोल्यूशन से हमारा फंक्शन मिल जाएगा जो फिल्टर्ड फंक्शन होगा, मतलब टोटल जो फंक्शन होगा हमारा फिल्टर्ड ग्रेविटी डेटा फंक्शन जो होगा वो मिल जाएगा. और बस
हाँ,
वही हमें स्टडी करना है. सो ये है इसका पूरा जो चक्कर है, इसके अलावा कुछ नहीं है इसमें, बहुत सिंपल है. तो एक्चुअली ये सब मैथमेटिकली और जितने मेथड मैंने बताए ना, हमें जो ऑब्जर्व्ड हमारा जो रीडिंग आई है ना, जो ग्राफ मिला है अभी, लाइनें क्या रिप्रेजेंट कर रही है, हमें उसे मैथमेटिकल फॉर्म में बदलना है. वो अल्टीमेटली काम तो सारा कंप्यूटर्स को ही करना है.
हाँ,
हाँ, तो
ओके,
वही हमें करना है बस. जो हमें डेटा मिला है उसे किसी तरह हम उसका कोई अप्रोप्रिएट फॉर्मूला डिजाइन करेंगे और फॉर्मूला डिजाइन करने के बाद उसे फिल्टर फंक्शन अप्लाई कर देंगे. और वो हम क्योंकि वो स्पेशल डोमेन में है तो हम फ्रीक्वेंसी डोमेन में ले जाएंगे दोनों को, क्योंकि डेटा फंक्शन को भी हमने कन्वर्ट कर लिया, उसे भी फ्रीक्वेंसी डोमेन में ले जाएंगे फॉरवर्ड ट्रांसफॉर्म के थ्रू. फिल्टर फंक्शन को हमें पता ही है क्योंकि वो अपनी चॉइस का यूज कर रहे हैं हम. फिर दोबारा कन्वोल्यूशन करेंगे और हमें जो मिल जाएगा अपना डिजायर्ड फंक्शन, इसे हम बोलते हैं फिल्टर ग्रेविटी डेटा फंक्शन मिल जाएगा. और उससे हम जो भी इंटरप्रिटेशन वगैरह करनी है हम कर सकते हैं.
ओके, ओके.
आई थिंक टॉपिक तो ऑलमोस्ट पूरा ही हो गया हमारा.
हाँ.
सो ओके, मैं रिकॉर्डिंग रोक देता हूँ.